In the previous lesson, you improved your control over the arm using feedback from the limit switch, preventing the arm from going too low. However, it's still possible to raise the arm too high, increasing the possibility of dropping the ball as your robot moves. In this lesson, you'll use feedback from the potentiometer to control how high the arm is able to raise up. But first, let's cover some of the basics about the potentiometer. The potentiometer is an analog sensor, plugged into analog port 6 on the VEX cortex, and on the same shaft as the robot's arm. It measures rotation between 0 and 250 degrees and returns values ranging from 0 to approximately 4095. Internal mechanical stops prevent the potentiometer from rotating a full 360 degrees and from reaching its peak sensor values. The orientation of the potentiometer will determine whether it counts up or down as the arm lifts. Before we begin, the potentiometer on your robot should be installed so that the arm is able to take full advantage of its range of motion, without hitting the mechanical stops inside the sensor. If your robot's arm reaches one of the mechanical stops along its range of motion, you should adjust it now, as running the motors against the mechanical stops can damage the sensor. In the previous lesson, when we used the limit switch to determine when the arm should stop, we knew ahead of time that the sensor would return a value of 1 when pressed. With the potentiometer, however, variance between the sensors and how they're installed will cause the appropriate sensor value to fluctuate from robot to robot. To determine the ideal sensor value for our robot, we'll use the Robot C sensor debug window. But remember, the value for our robot may be substantially different than yours. Make sure your robot is turned on and connected, and in Robot C, compile and download your fine-tuned arm control program to establish a connection. Then go to Robot, Debug Windows, Sensors, to open the sensor debug window. Check that the second button under Refresh Rate on your program debug window says Pause Refresh and not Continuous. Then press the Start button. The sensor value of the potentiometer will be displayed in real time under the Value column of the sensor debug window. Now place the robot next to a mine so that the arm is positioned to lift the ball off of the post. While also watching the sensor debug window, physically raise the arm so that it lifts the ball up, with some additional room for clearance. As you do, make note of whether the sensor value is increasing or decreasing as you raise the arm, as well as the final raised sensor value. Now that we have the raised sensor value for our robot, we can implement feedback from the potentiometer in our program. Since we want to control how high the arm is able to lift, we want to focus on the section of our code that controls raising the arm. Our first if statement checks if the Group 6 up button is pressed and raises the arm if it is. Like the last lesson, we don't want to replace the existing condition. We want the if statement to check if the up button is pressed and the potentiometer value hasn't been reached. Once again, we will need to use the AND logical operator to combine our two conditions. Add an AND logical operator after the first condition using two ampersands. Next, start adding in the second condition. Sensor value, arm pot. Now here's why paying attention to whether the sensor value was increasing or decreasing as you raise the arm was important. If the value of your potentiometer increased as you raise the arm, then the condition needs to check if the current sensor value is less than the desired sensor value. But if the value of your potentiometer decreased as you raise the arm, then the condition needs to check if the current sensor value is greater than the desired sensor value. The potentiometer's sensor value increased as we raise the arm on our robot, so we will use the less than operator in our condition. If your potentiometer sensor value decreased, you should use the greater than operator. Finally, add the sensor value you found when the arm was in its desired raised position to complete the condition. Our first if statement can now be understood as, if the up button is pressed and the potentiometer sensor value hasn't been reached, raise the arm. Time to try it out. Compile and download and run. Pressing the Group 6 up button raises the arm until the potentiometer value is reached, Success! Note that if your robot's arm goes past the desired position, you may consider lowering the speed of the arm motor. In this lesson, you learned how the potentiometer works and used feedback from the sensor to control how high your arm is able to lift.